Let's talk about the essential fatty acid in this video. Hey guys, please make sure that you subscribe to this channel, turn on the notification button. I don't know what is stopping you from subscribing, so that you'll be notified whenever I post a new video. Now, before I continue with this particular video, I just want to admonish us on something, and that is the fact that most persons, they don't really know what to do to get A's in biochemistry. Like I've said before, I've done biochemistry before, and in the 2 semesters, by God's grace, I was able to cater away with both A's in both semesters, even when the test was not as good as that. Now, how was I able to do this? It was a very simple thing I did. Now, the biochemistry questions, they look so simple, but they are not as simple as you see them to be. If they give you a question, don't just go straight answering the question based on how it was given. For instance, they may ask you, what are essential fatty acids? Now, when you explain essential fatty acid, you should be able to do what? Give the structure of the essential fatty acids. Is that okay? Give the deficiency of those essential fatty acids. You should give as many notes as possible under the word essential fatty acid, because that question may just be the only question on that person's part. They may just say, what are essential fatty acid? Draw their structure, and that is the only question on that person's part. And if you answer it based on that, let's say the mark awarded there will be 15 marks. If you just answer essential fatty acid that is and that is finished, you'll be given like 2 out of, let's say, 15 on 10. So it's better you draw structure, state the if there is a structure, draw structure to illustrate, contrast and compare if there is, and also state deficiency if there is. For instance, in this case of essential fatty acid, don't answer their questions based on the way it was given, unless otherwise you ask questions like state the functions of this. Those ones are questions that you can go direct. But the ones that they will ask you, what are monosaccharide? Classify monosaccharide. Don't just go into what are monosaccharide and this and then classify. Please make sure that you write as much as you can. Not irrelevant details. Your work should be precise, straight to point, but at least give all the vital details that you know particular to that particular questions that will be what answered. So that is one of the methods I use. I use in the both semesters, and I was able to score very high in both semesters. Okay, so please, now let us talk about essential fatty acid. Let our mind be back. Now, what are essential fatty acids? Now, we've talked about essential amino acid before. We've talked about the essential amino acids, where we said there are those amino acids that cannot be synthesized by our body, hence they should be taken in our nutrients or in our diet. Same thing is particular for what? Essential fatty acids. There are those fatty acids that cannot be synthesized by the body. Hence, fatty acids that cannot be synthesized by the body, hence we need to take them in. Hence they should be taken in our diet. They should be taken in our diet. They should be taken in what? Our diet. All those ones, they are the what? Essential fatty acid. Now, why is it necessary? What's the biological necessity of this fatty acid? Why should we take them in, and why are they not synthesized by the body? Now, normally, the body cannot introduce double bonds beyond carbon 9 and carbon 10. What it means is the enzyme that we introduce this double bond on this fatty acid from carbon 9 to carbon 10, aside from carbon 9 to carbon 10, beyond that, the body does not have that enzyme. What we mean by that statement, let us go back to what we did initially. For, I think, which one is this? Let's talk about okay, this, I think this is linoleic acid. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Now this linoleic acid is one of the essential fatty acid. Now if we look at linoleic acid very well, you discover something, that at position number 9 and 10 you have a double bond. Now the body lack the enzyme to introduce a double bond after this position 9 and 10. It means that it cannot introduce a double bond from position number what? This is 9, 10, 12 and what? 15. 12 and 13 rather. Is that okay? It cannot introduce a double bond beyond 10. So this double bond 12 and 13, there is no enzyme in the body that can introduce what? This double bond. And hence, we have to take linoleic acid into our body in order for it to what? To carry out the function that it needs to carry out. Is that understood? So it means that normally the body can actually synthesize fatty acid with double bond. But those fatty acid that it synthesizes with double bond cannot be what? Beyond 9 and what? 10. That means the double bond present cannot go beyond 9 and 10. So it means that our body cannot synthesize 12 and what? 13 and even 15 and whatsoever. As in the case of, we did one that got up to 15 and 16. This, the one, linoleic acid. Okay, this is arachidic. Okay, maybe but this one, we understand the concept from here now. Those fatty those essential acid or essential fatty acid are fatty acid that cannot be synthesized by our body, because the body cannot synthesize double bond beyond carbon 9 and 10, and hence must be taken in our diet, are essential fatty acid. Now there are two essential fatty acids. There are two essential fatty acids. They are linoleic acid, which we have drawn the structure before. This is the structure of linoleic acid. Where is it? This is the structure of linoleic acid. Then we have linolenic. I think we did linolenic, but I can't find it. But it's among those fatty acids we drew the other time. Linolenic. We said linolenic is what? Is here. So if you listen to the first video, you should be able to draw the structure. Linolenic. You have 18:3, 9, 12, and 15. That is linolenic. Okay? So those are the two essential fatty acids, linoleic acid and what? Linolenic. Now this is most of the questions that we set under fatty acid usually come from here. What are essential fatty acids? Draw their structure. You've seen how we draw the structure in the first video. And we have linolenic acid and linoleic acid. Now the linolenic, they have two types. Linolenic, rather, they have two types. We have the alpha linolenic and the gamma linolenic. But the one that is essential is the alpha. Now in some cases, arachidic is also what? Essential fatty acid. Sometimes it's conditionally essential. Are we getting it? The structure of arachidic acid is the arachidonic acid, rather, is this. You see that this one, it has carbon bond or double bond beyond what? Position 9 and 10. This is position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see there's a double bond at position number what? 11. At position number 11, 12, 13, 14. Or let's say this 11, 12, 13, 14. At position number 14, you also have a double bond. So all these ones that have double bonds that are greater than carbon 9 and 10 are what? Essential fatty acid. Is that understood? So that is that. Now, the lack of essential fatty acid results in a medical condition called phrenoderma. Phrenoderma or toad skin. Phrenoderma or toad skin. So the lack of essential fatty acid gives rise to phrenoderma, and you can see, you look at some people's underarm like this, you see some things like crocro, rashes, is lack of essential fatty acid, like you can see here. Are you getting it? You see that lack of linoleic or linolenic. acid. So all these kind of body rashes is either you call it phrenoderma or you call it toad skin. It's lack of the essential fatty acids. Is that okay? Now let us look at triacylglycerol. Now what are triacylglycerol? As the name implies, triacyl means 3 acyl group with what? Glycerol. Now esters of fatty acid and glycerol are called what? Esters of fatty acids and glycerol. What did we call them that time? We said they are what? Simple lipids. Is that not so? Now in this case they are called triacylglycerol. So we can say triacylglycerol are esters. Triacylglycerol, they are esters of fatty acids with what? Alcohol or with glycerol. The fat and oil chemically distributed in our body is what? Is triacylglycerol. The fat and oil that is chemically distributed in our body is triacylglycerol. Now, if you watch the first episode of this video, we classify lipid as simple, compound, derived, and miscellaneous. And then under simple, we said their esters of fatty acids are what? Glycerol. If you can still remember, fatty acid and glycerol. And then we said example is what? Fats and oil. And then the last one is what? Oasis. Now we want to take fat and oil now, which are the fat and oil chemically distributed in our body are triacylglycerol. So we are taking the simple fatty acid now, and under this we are taking what? Triacylglycerol. Now, what is the triacylglycerol like? It has glycerol. This is structure of glycerol. Esterified with fatty acid. It has glycerol esterified with fatty acids. Now there are 2 or 3 types. We have the normally acylglycerol. Let me start by saying acylglycerol first. Acylglycerol. Now acylglycerol are of 3 types. We have the monoacylglycerol. We have the diacylglycerol, and then finally we have the triacylglycerol. Now the triacylglycerol are the one for fats and oil. Now what is the discrepancy between these 3? Now if you watch the first episode of this session, I said that when carboxylic acid reacts with alcohol, what is formed is what? Ester, with the elimination of water molecule. Is that not so? With the elimination of water molecule. When carboxylic acid reacts with alcohol, what is formed is what? Ester, with the elimination of water molecule. So this will form ROC double bond O and what? R. Now, we said that the carboxylic acids are also what? Fatty acids. So we can decide to add fatty acids here now in place of carboxylic acid. And then this OH of glycerol can react with the COOH of carboxylic acid to form the acylglycerol. And I said there are of 3 types: monoacyl, diacyl, and triacyl. Now let me look at monoacyl. Let's look at monoacyl. Now monoacyl are those that this only one of this OH is esterified with a carboxylic acid. Only one of these is esterified with a carboxylic acid. So this one now will form CH2. Then what is this now going to form? It will form O, C double bond O, and then what? R. OH will leave here. Is that not so? Then this one will form R, something like this. Then you now have CH, OH, normal, and then CH2, OH. So this is an example of a monoacylglycerol, where this group here can be any of the fatty acid, but in most cases it's usually a saturated fatty acid at carbon number 1. Are you getting it now? So that's an example of monoacyl. Where this group here is a fatty acid. So if I put palmitic acid here now, it means this will be what? A monoacyl glycerol of what? Palmitic acid. Is that okay? Now let us look at the next one. Let's look at another example. Let's say diacyl glycerol. Diacyl glycerol. Now, diacyl glycerol is, we have two groups or two fatty acid esterified with glycerol. How many fatty acid? Two fatty acid esterified with glycerol. So when you have something like this, you call it what? These two will react, and of course you know what it will form. It will form O, C double bond O, arrow. These two, CH, O, C double bond, then arrow prime, and then CH2 and what? OH. Now in most cases this one is usually saturated, while this is what? All saturated. We talk about all this when we talk about triacyl glycerol. So all these are what? This diacyl rather, when you have two fatty acid esterified with glycerol. Two fatty acid esterified with glycerol. Now how about you have three fatty acid esterified with glycerol? That one now will give us triacyl glycerol. And triacyl glycerol are of two types. We have the mixed triacyl glycerol, and we have the simple triacyl glycerol. Now the simple triacyl glycerol has the same kind of fatty acid esterified at all the three carbons of glycerol. So let's say the fatty acid is palmitic. It means only palmitic acid is esterified here. Are you getting it now? That one is simple monoacyl. So in this case, let's say you have palmitic acid. Palmitic acid is this, and then you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This palmitic acid plus another one. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Plus another palmitic acid. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now you see the way it is. Just assume everything here is 16, 16, 16. Now when these two esterify together, what are you expected to form? You have to form a group here, according to what I told you, that this will be what? O, and here will be what? C double bond O, and here will be what? OH. Is that not so? Same thing applicable here. When this one reacts with this, it will form O, C double bond O, and then of course this group here means this one is attached here, because of this thing, the way it is, it's attached here. Please take note. So this one will be what? O, C double bond what? O. Then this group here is what? Attached. So this one now form a triacyl glycerol. This kind of triacyl glycerol is called a simple triacyl glycerol. Now a triacyl glycerol that have different fatty acid linked is called a mixed triacyl glycerol. For instance, let's assume here you have assumption now. Let's say you have C double bond O. Let's say this is one fatty acid. What did I draw here? Hope that was not what I drew. Please, let's take note. If you have O, C double bond O, arrow prime, O, C double bond O, arrow prime prime, O, C double bond O, arrow prime prime prime. Now these three groups here are all different. It means that three different fatty acids are esterified with glycerol. Is that okay? Such a fatty acid is said to be a triacylglycerol. That acylglycerol is triacylglycerol, and it is a mixed triacylglycerol. In most cases, the carbon 1, which is this group here, is usually saturated. Okay, take note of this. And this one is what? Unsaturated fatty acid that will be here. And then the last one can either be saturated or what? Unsaturated. Let's take note of that. Is that okay? So here, palmitic acid can enter here. Here, oleic can enter because oleic is unsaturated. Palmitic acid is what? Saturated. In the same way, palmitic acid can enter here. Why here? Palmitoleic acid can get in here. Why here can either be palmitic or palmitoleic. Is that okay? So let us look at phospholipids. Phospholipids. And I believe that is where we are going to end the lecture. Phospholipids. Let me use about 30 minutes to explain what phospholipids are. Now, according to what I said, that they are what? Derived lipids. Phospholipids are derived lipids. Complex rather. They are complex lipids. And they are classified into two. We have the glycerol. If you've watched the first episode, phospholipids. And then here you have the sphingophospholipid. We said glycerophospholipid is the one that have glycerol as the backbone, while sphingophospholipid have sphingosine as the backbone. Now, the phospholipid, they contain what? Glycerol for glycerophospholipid plus fatty acids plus then we have a nitrogenous base, and then finally we have glycerol, fatty acid, nitrogenous base. What other thing am I forgetting for the glycerophospholipid? Nitrogenous base, fatty acid, glycerol, and then phosphoric acid or phosphate group. Phosphoric acid. Now, the nitrogenous bases that are present are, let me give you an example of the nitrogenous base. Now, these nitrogenous bases are not purine and pyrimidine base. Are we getting it? Nitrogenous bases are choline. Now, structure of choline is CH2, CH2, then N, CH3, bracket 3 plus. It's not that clear. Let me write it out here. CH2, CH2, N, CH3, bracket 3 plus. This is choline. This is the nitrogenous base. Then we have ethanolamine. 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 As name implies, enthelamine. That is what it means. CH2, CH2, and what? NH2. Then we have serine. Serine is a nitrogenous base from the amino acid that is serine. Serine is what? Is if you want to talk about amino acid now, COOH, there is what? NH2, and then what? H, and then we have CH2OH. This is what? Serine. This is structure of serine. It's an hydroxyl amino acid. So all these ones, they are the nitrogenous bases. Let me rename them again. The nitrogenous bases we have are nitrogenous bases we have, we have serine, we have choline, we have ethanolamine, we have INISITOL too. INISITOL, and then we have glycerol as part of them. Now, this INISITOL and glycerol, they are what? They are somehow related to what? Carbohydrate. But these three are the major nitrogenous bases we have. Okay? Now, let us see the structure of each of these glycerophospholipid. We've already established what glycerophospholipid are. Now, in most cases, I'm not going to start now drawing each of them. I'm just going to show to you how it is. Now, let us talk about lecithin. Lecithin is phosphatidylcholine. It means that the nitrogenous base present is what? Choline. Now, we have glycerol. This glycerol, CH2OH. CHOH. And then CH2OH. Now, I'm going to take this one slowly. Now, at carbon number 1, what is there is a fatty acid, which we said is usually what? A saturated fatty acid. It can be, let's say, palmitic acid. In most cases, they will say, draw the structure of a phosphatidylcholine having palmitic acid at carbon number 1. So it means that carbon number 1, what do you put there? Palmitic acid. I've drawn the structure like that before. You should check our video on lipids prep, exam prep is here. Now, they will now say, draw, let's say, oleic acid in carbon number 2. So you now come here and say this is oleic acid. If I draw this, know that I'm talking about a particular fatty acid. So this is oleic acid. And then they will now say choline at carbon number 3. Are you getting it? Choline at carbon number 3. It's like we jumped one, phosphatidic acid. Let's come to phosphatidic acid first before we come here. So as I was saying, you have CH2O for this one. This is what? Palmitic acid, for instance, is an instant. It can be any one of them they wish to give to you. This one is what? Oleic acid. And then finally, you have CH2. Now for this one, what is attached here is a phosphate group. So you have the phosphate group minus, and then you now have the nitrogenous base attached. Now in this case, it's phosphatidic acid. You end it here. Phosphatidic acid serves as the backbone for the formation of the rest, because it is to this phosphate group that all the nitrogenous bases are being what? Attached. Is that okay? So phosphatidic acid serves as the backbone. Like I said, this is the structure of phosphatidic acid, where each of these one can be any of the what? Fatty acid. Here can be oleic acid. If they say put oleic acid here, you don't put arrow prime, you draw the structure of what? Oleic acid, which I've drawn before in our first episode. Then this one is what? This one may be palmitic, because I usually said it should be what? Saturated. You draw the structure of palmitic acid. Don't put arrow prime here and then put palmitic acid. Draw the structure. Because of time, I'm conserving time. That is the reason why I have to just write palmitic and what? Oleic. Then this one is a phosphatidic acid. It's the backbone for all other phospholipids. So I'm going to add any one of them here. For instance, when they say phosphatidylcholine, it means choline will enter here. If they say phosphatidylinisitol, inisitol will enter here. If they say phosphatidyl, anyone they give to you, that will what? Enter here. Okay? So let us talk about the one we are talking about, lecithin. Now, lecithin is also called phosphatidylcholine. Now, it means that choline would be at this position when the phosphate group, the phosphatidic group is what? P, A, then we have what? This and this minus. So you attach choline to this position. What is the structure of choline? I gave CH2, CH2, and then you have N bracket CH3, 3 plus. In some textbooks, they will bring it out to be CH2, CH2, and CH3, CH3, CH3 plus. Okay, but if you write it like this, it's also correct. Now the next one is phosphatidylethanolamine. Now, as tradition demands, you also have C. There here is what? O, double bond O, arrow prime, one fatty acid. We have CO, C, double bond O, arrow prime prime, another fatty acid. Then you now have what? CH2, O. Then you have what? Phosphate group, O. There is what? O minus, and what? Ethanolamine, which is CH2, CH2, and what? NH2. So this is phosphatidylethanolamine. It is also called CEPHALIN. So if they say draw the structure of CEPHALIN with a fatty acid, they will give you the fatty acid that carbon number 1 is this. Let's say palmitic. The one that carbon number 2 is stearic or oleic. They will give to you. Is that not okay? Now let us talk about the next. Phosphatidylinisitol. Phosphatidylinisitol. Now the structure of inisitol is this. This is the structure of inisitol. You have OH here, H. There here you have OH, H. Is more like glucose, but it's not the same with glucose. Then you now have this group here, it is attached, and then you have OH here, and then H, and here is what? OH and H. So you attach this one to the phosphate group, it gives you phosphatidylinisitol. So how do we now draw the structure of phosphatidylinisitol? C double bond O, sorry, what am I drawing? This will give us CH2, O, C double bond O, and what? Arrow for the first fatty acid. Second one will be CH, O, C double bond O, arrow, second fatty acid. And finally, you have inisitol attached to the phosphatidic group, or to the phosphate group of phosphatidic acid. This minus here, and then you have inisitol attached. Now, which of the parts of inisitol is attached? Is the OH group on top. Okay, the OH group on top. It is esterified. It means here is what? H, and then it is esterified with this one. There you have this H. So it means that all these ones, they will be here like this. If I want to draw the structure again, and then this structure is so fine. This gives us this, comes here, and then you have this, and then finally you have this. Now every other thing still remains. H, OH, OH, and H, and then you have H, OH. Here will be what? H. Here will be OH, H, OH, and H. And this is the structure of phosphatidylinisitol. Okay, so we have the last one, phosphatidylserine. Still the same thing. We draw the first fatty acid chain, arrow prime, which I said can be any of the fatty acid that is saturated. This can be unsaturated, anyone. Then we now attach serine to it. Structure of serine is, the fatty acid serine is this: COOH, C, NH2, and then we have what? H, and what? CH2OH. Now, from what we know, which of them do you think will actually esterify with this? This is not the OH group. The OH group is what we esterify with it. Okay, this is not supposed to be COOH. This is fatty, the fatty group, minus. Then you now have what? This group is esterified, so it means from here will be attached. So you have it as what? CH2. First of all, you have your O. Then, okay, there ought not to be oxygen here again. Please take note of this because it's esterified with what we have there. This one joined together with this. Okay, so we have O, and then we now have CH2. Which is CH2, then C. What do we have here? Hydrogen, then what? NH2. This hydrogen NH2. Then what do we have here? COOH. So this is the structure of phosphatidylserine. From serine, the amino acid. Is that okay? So I believe that is all for this particular one. Phosphatidyl, inisitol, serine, and ethanolamine. Now, the past question say, what are nutritional essential fatty acids? We say they are fatty acids that the body cannot synthesize, hence they should be taken in our diet. An example is what? Linoleic acid and alpha-linolenic acid. Now we are asked to draw their structure. The structure of linoleic acid is this COOH. Linoleic acid is 18 to 9 and what? 12. 1, 2, 2, 3, 4, 5, 6, 7, 8, 9. We have a double bond. 1, this is 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, we are supposed to have number 12, a double bond again. This 9, 10, 11, 12, double bond. 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is the structure of linoleic acid. Now the next one is alpha-linolenic. That one is 18:3. Then we have 9, 12, and 15, which should be COOH. Then we have COOH. Then you have 1, these 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you have a double bond here. Then 10, 11, 10, 11, then 12, a double bond. 13, 14, 15, a double bond. 16, 17, and finally 18. If I want to count it, this is 1, 2, 3, 4, get out. 1, 2, 3, get out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So this alpha-linolenic acid, okay, alpha-linolenic acid, and these are the two essential fatty acids. So if you are asked the exam hall, this is what you expected to give. Okay, explain the health benefit associated with regular intake of nutritional essential fatty acid. What are the health benefits? It helps in the synthesis of what? Vitamin. It helps in the synthesis of vitamin, and also it prevents the lack of it, which is what did I say was the lack of vitamin, the lack of essential amino acid. I said it leads to what? Phrenoderma. So if you take it to prevent what? Phrenoderma. All those are the health benefits of taking essential amino acid. And then including this one, you can now state other functions of what? Not amino acid, essential fatty acid. Now you can now start stating other functions of this fatty acid for synthesis of lipids and other things in our body. Okay, so that is basically all for now. Now other past questions are in exam prep. You will see lipid exam prep. So you should check it out. Lipid exam prep, you should check it out. It has other past questions that I've solved before. So thank you for your time.